Welcome to our last section of Chapter 1, Section 1-6 Polygons. This is kind of a weird section. It's in this chapter because it has to do with angles and vertexes and different things. It's kind of a break from the other stuff. We don't talk quite as much about, adjacent and all those kinds of things. But we're going to talk about polygons. I am hoping that a lot of this is review for you. You've seen this throughout the years. Other times you've done things. So let's try to get through this. So first of all, a polygon is any kind of closed figure formed by segments. No curves. It's a closed figure formed by segments. We know that segments are pieces of lines. We know that lines are straight. There are two important things that go along with this. The sides with common endpoints are non-collinear, so you can't have two sides that just continue on in a line. In other words, like GH is like this, and then HK is like this, and it's just one big line. So they're non-collinear. You have to have a vertex, some kind of corner along the way. And the second thing is each side intersects only at the endpoints. So I'm going to kind of skip ahead here in this non-example. A non-example based on that would be that is not a polygon because our sides intersect not only at the endpoints, but in somewhere in between in the middle of those sides. The other non-example that I could add, notice it has to be a closed figure. So something like that is not a polygon, that's not closed. Everything has to have an endpoint meeting another endpoint. The symbol, I don't know if symbol's the right word, I should have said named by. This is named by the letters of the vertices in order. It doesn't matter where you start and where you end, but you have to go in order. It's like if you were tracing around the outside of it with a pencil, you can't skip. So notice right here, it's already written out. This is polygon. It's got a lot of sides, like 6. G, H, J, K, L, M. So they started G, H, J, K, L, M. You go around the outside. We could have named it Polygon M, L, K, J, H, G, but I can't name it M, K, G, H, L, J. You have to name it in order. So let's say I'm going to draw a 5-sided, whoops, I better draw a closed figure. A 5-sided figure, which hopefully you know what that looks like. I'm going to label that one like this. And I could call that polygon, I'm going to call it DEABC, or which one's right? How about CAEDB? One of those is good, one of those is bad. Which one is the proper way to name that polygon? DEABC goes around the outside of it. I like that. C over to A jumps across. I skip B or I skip the other way. So that's junk. I'm going to say not in order. That's going to come in handy later when we get into other types of polygons. And if I just give you a word problem, you have to know how to name that. So polygons. And then we've got some things that go along with them. So what types of polygons? How are they drawn? What do they look like? So concave and convex. These two things go together, and you may have heard of convex in context of lenses in science class, perhaps. Concave is when a vertex is in the interior of the polygon. So it kind of collapses inside itself like this top example. Convex, and I think of it like a cave, like you have to go into a cave. I don't know, it works for me. Convex, we've got no vertices in the interior points. It just kind of goes around. Even if it's awkwardly shaped, it doesn't go inside that polygon. A regular polygon, this term will come up quite often. A regular polygon, whoops, means that all sides and all angles are congruent. I'm going to ask you in some problems to identify, is this regular and is this concave or convex? So if I look at this top example over here, is this a regular, well, we'll start with concave or convex. So is this concave or convex? Because this goes into the interior. This is concave. Is this a regular or not regular polygon? I notice that all the sides are congruent, right? They all have the single dash on it. However, all the angles also have to be congruent. I've got these single arcs, and then I've got these double arcs. So that tells me those angles aren't congruent. Also, this is not marked, and that's not marked. So obviously, those aren't congruent because one's greater than 180 and one's less than 180. So I would say this is not regular. This bottom example, concave or convex, well, it kind of just goes around in a shape. It's kind of a nice shape, but this one is convex. And then I would ask, is this regular or not regular? I notice all of my sides have single dashes. They're all congruent to each other. All of my angles have single arcs, which means they're all congruent to each other. So this is a regular polygon, a regular convex polygon. Then I kind of snuck perimeter, circumference, and area right into the same thing. Hopefully you remember from past years that perimeter is the sum of your sides. So you just add up all the sides of your polygon. If you've got 5 sides and they're all 10 units long, then you know it's 50, the perimeter is 50 units. If they're all different, you add up all different. Circumference has to do with circles. Circumference is actually the perimeter or the distance around the outside of a circle, which is what the perimeter is. If I were to walk around the outside of a polygon, I would get the sum of those sides. If I walk around the outside of a circle, that would be the circumference, the distance around it. And area is the number of square units needed to cover a surface. If you look at a floor, like say in a school, there's tiles on the floor. Each one is 1 foot by 1 foot. So it's 1 square foot. So we could count up how many tiles, how many square feet are needed to cover the floor of a classroom or a hallway or a cafeteria. So we've got a few formulas. I left some boxes blank here. Triangles, squares, rectangles, and circles. You probably are very aware of most of these. Maybe just a quick refresher. So if we do this as perimeter and this second as area, so these guys right here, all 3 of these, we don't have to make it difficult. Let's just say the perimeter of triangles, squares, and rectangles is equal to the sum of all sides. Doesn't matter what kind of polygon you've got. Is a circle a polygon? Is it a closed figure formed by segments? It is not, right? Circles is kind of like the oddball in this section. They put it in here just because it's a review. Hopefully you remember the perimeter of a circle is the circumference. So circumference equals 2 pi r. R stands for radius. Radius is the distance from the center to the outside. Would you agree that from the center to the outside is the same as the center to the outside in another direction, right? So 2 radiuses make up a diameter. Diameter is all the way across through the center. Some people might like a pi times diameter, pi d. It doesn't matter which formula you use, it's just taking into account that 2 radiuses equal 1 diameter. If we're talking about area of a triangle, I do area and then I do a little triangle down here so you remember. There's a couple different ways. I don't know how you learn this, but I always do base times height divided by 2. Some people learned it as half times base times height. So the base is usually the bottom or the horizontal side. The height has to be perpendicular. So make sure you're looking for that perpendicular height. When the doctor takes your height at the doctor's office, you never stand slanted. You always stand perpendicular to the floor. We don't need to be complicated with our areas of squares and rectangles. People learn this different ways, and I don't actually love what they put here because we do it differently later. So I'm going to take that off. I'm going to call this B and H. B equals base, just like in the triangle. H equals height, just like in the triangle. So we're going to say area of any kind of rectangle or square is just the base times the height. I know you might have learned it as length times width. You'll probably continue to think that, but bases and heights we use later on this year. And then last but not least, the area of a circle. That one's a little trickier, a little messier. The area, it looks sort of like our first circumference formula. It's pi times r squared. So you're going to do your radius squared times pi. Use the pi button on your calculator, not 3.14. If you need help finding that, let us know. We will make sure you find that. Area is always squared. Remember, I mentioned the tiles on the floor are 1 foot by 1 foot, 1 square foot. So I always remember area is squared. That's why it has a squared exponent in the formula. So we'll do some problems with these. Hopefully, again, they are just review problems. You've seen them before. Let's skip this one. Well, maybe we should do this one. A landscape designer is putting black plastic edging around a rectangular flower bed that has lengths of 5.7 meters and a width of 3.8 meters. Find the perimeter of the garden. All right, well, if you haven't figured me out yet, I like a diagram. We're putting black plastic edging, so we want to put all the way around the outside of this yard, right? So we need to know how much we have to buy. You don't want to buy too much. You'll have stuff left over. It would be a waste of money. It says that it has a length of 5.7 and a width of 3.8. Find the perimeter of the garden. We said that the perimeter of any rectangle or square is always the sum of the sides. However, don't forget, and I'm going to use some geometry nomenclature here, if this is 5.7, the bottom, how big does the top have to be? 5.7, right? If this is 3.8 over here for the width, it's got to be 3.8. So don't forget, when you find the sum of the sides, if you've got 4 sides, you've got to do 4 values. You might do that differently on the calculator. You might say two values of 3.8 plus 2 values of 5.7 is going to be equal to the perimeter or the distance around the outside. Whichever way you like it, you could say 5.7 plus 3.8 plus 5.7 plus 3.8. You get the idea, right? I believe that comes out to 19 meters if I did my math right. We can skip B. We could triple them and then try it again and see what happens, but just finding that and knowing what it's asking. I wish I had changed this and not asked for the perimeter. I wish I would have said, how much edging does he need for this landscape designer? Because then you would have had to know that you were finding perimeter. Made that one too easy. All right, so now special types of polygons. We've got names for things. Notice I've got this already labeled in mine, 3 through N. So let's do a quick run through because you probably know over half of these, if not more. So a 3-sided polygon, 3-sided figure is always called triangle, right? 4-sided, people have different names. You're going to say rectangles, squares, trapezoids. In general, any 4-sided figure is a quadrilateral. Quad means 4. 5-sided figure, you may know, pentagon, like the Pentagon building in Washington, D.C. 6-sided, people tend to always know this one. I always remember the X's go together. Hexagon. 7-sided figure, people often don't know a 7-sided figure. It's a weird one. Similar to 6, it's a heptagon, H-E-P-T agon. Notice most of these end with gon. It's intentional. 8-sided figure, think of an 8-legged creature, octagon. Some people remember it by octagon by like MME and stuff. 9-sided, I like this one. It's got a nice ring to it. 9-sided figure is a nonagon, N-O-N-A-gon. 10-sided figure, like 10 years, decade. This is a decagon. 11-sided figure is one of my favorites. This is a hendecagon. Hendecagon. And 12-sided, say it out loud because it's a fun word to say. A 12-sided figure is a dodecagon. So 10 is decagon, and then 11 and 12 have the prefixes hendecagon and dodecagon. And the book will often refer to an n-sided figure. You know, find something about this n-sided figure. So just like the generic term, we call it a n-gon. That's only for when the book types things up and says, find the measure of an interior angle of an n-gon or something like that. All right. So let's just do letter B. It says to name each polygon by its number of sides, classify it as concave or convex, and then regular or not regular. So first of all, how many sides does this little guy have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So 12-sided figure. Hopefully you are getting down a dodecagon. Is this concave or convex? Remember, concave is like a cave. It goes in on itself. Convex is more of a rounder shape. So this definitely looks concave to me because we have all these little corners that are going in. And is it regular or not regular? Remember, regular means all sides and angles are congruent. Well, just looking at it, I can tell that all the sides aren't congruent. I can also tell that all the angles aren't congruent. So this is, it says irregular. You could say not regular. It's all the same thing. So yes, at some point you will be responsible for knowing the different, like if I say a nonagon, you're going to need to be like, oh, well, that's a 9-sided figure. I know what to do with that. Last but not least, I don't think that we need to go through this whole thing, but I do want to run through some quick steps. It says for the directions to draw a triangle PQR, so we can do that, right? Tells us where the ordered pairs are. We're going to put in the point. We're going to write the letter. We're going to draw the triangle, then determine its area and perimeter. So instead of me just saying, oh, well, the sides are 3.8 and 5.7, you're going to have to figure this out. So the first thing that you should do is draw the triangle using the given points, label everything, draw it all in. The second thing is you're going to need to find the length of each side. So in order to do that, go back to section 15A. You're either going to use the distance formula or Pythag, whichever one you feel more comfortable with. And then the third thing is going to be to do what it asks. Use the formulas to find capital P perimeter and capital A area. Those are capitals. If you are one of those people who mixes up your caps and your smalls, this is the time to stop mixing them up. It makes a difference. If you use a small letter A for a point, I am not going to know what you're talking about. I'm going to say that is not a line. So start using your capitals and smalls. We don't necessarily need to go through this. We'll practice this as we go, but it's good to know what you need to do on those. That is it for section 1.6. I know there's another example. We'll skip over that one. And thanks for being here for chapter 1. That was fun. We'll see you next time.